A polygon with all its sides congruent to one another is equilateral. That is, that's equal, and lateral sided, so equal sided. A convex polygon whose interior angles are all congruent is equiangular. So the equa there is equal, angular is angled, so equal angled. A regular polygon is a convex polygon which is both equilateral and equiangular. So some examples of regular polygons are shown here. A regular triangle is also called the equilateral triangle, and a regular quadrilateral is also called the square. Beyond that, we just say like regular pentagon, regular hexagon, regular heptagon, regular octagon, and so on. So, tell whether the polygon is regular. Well, part A, it's equilateral. All the sides are congruent, but the angles do not look, there's no mention about the angles being congruent. So, the best we can say is that it's equilateral. We don't know if it's equiangular. For part B, we know it's equilateral. We know it's equiangular by the marks on the shape. So, part B is regular. Okay. In terms of parts of a regular polygon, a regular polygon, besides interior angles, there are other interesting angles in a regular polygon. One such angle involves the center of a regular polygon, which is a point that is the same distance from all the vertices. A central angle is formed by the line segments that join the center of a polygon with the two endpoints of one of the sides. So basically we go from the center to, we draw lines to the two adjacent corners. And then that angle between them is the central angle. An exterior angle is supplementary to an interior. So if we have an interior angle, such as like right here, I would extend out the line segment and then we get an exterior angle. So recall, supplementary means that the interior angle plus the exterior angle would always add up to 180 degrees. So it is formed by extending any side of a regular polygon. Some notes, the measure of the interior angles. So we know the sum of the interior angles is 180 times n minus 2. So divide by n, that gives you the angle measure for each interior angle of your polygon. The central and exterior angles are a bit simpler in that they're just 360 degrees divided by the number of sides. So notice that central angles and exterior angles have the same formula. They're 360 degrees and you divide by the number of sides. The central angle of a regular polygon is an angle with a vertex at the center of the polygon. Some examples are given in the table to the right. So if there's 4 sides, the central angle is 90 degrees. And we get that by doing, try that again. There you go. We'd get that by doing 360 divided by 4. When there's 5 sides, so if it's a regular pentagon, the central angle would be 360 divided by 5. For 6 sides, we get that 60 degrees by going 360 divided by 6. For 8 sides, we'd be doing 360 divided by 8. That comes out to 45. So what is the measure of the central angle of a regular polygon with 20 sides? Well, that would be 360 divided by 20. So that's going to be 18 degrees. So these would be very sharp corners. So name the regular polygon with central angles that each measure 36 degrees. So we know in general central angles have a measure 360 divided by n. That's for central angles. So that's equal to 36. Multiply both sides by n. So we have 360 equal to 36n, and then n is equal to 10. So you could call this a tengon, but the technical term we'd use would be decagon. So deca, like in decade, the deca is 10, gon, 10-sided figure. Name the regular polygon with exterior angles that each measure 45. So exterior angles also have the formula 360 divided by n. So you multiply both sides by n, we'll have 360 equal to 45n. And then if you divide by 45, well, let's see. 45 goes in the 360. It looks like, let's try 8. 8 times 5 is 40. 32, 36, yeah. So 8 sides. So n would be 8. We can call that an 8gon, but more appropriately it's called an octagon. Now, name the regular polygon with interior angles that each measure 140. So if you recall, an interior angle, that's a bit more complicated, where we'll have 180 times n minus 2 over n equal to 140. You might find this easier to just plug in, do the guess and check method, but to solve this, we would multiply both sides by n. So we'll have 180 times n minus 2 equal to 140n. I would then use the distribution property. So 180n minus 360 is equal to 140n. And then add 360 to both sides and subtract 140n. I can rewrite it as 180n minus 140n equals 360. 180 minus 140n is 40n equal to 360. Divide by 40, you'll have n is equal to 9. So this would be a 9gon. Or I think nonagon is the correct term.